Okay, guys, so I wanted to take a moment now to break down some of the ideas behind vectors, right? So hopefully you guys had some time to look through the slides and the ideas presented in the chapter here on vectors. This is going to really help us out for 2D motion, okay? So what we want to do right now is we want to start building an idea of what a vector is and what are its components, right? So for 1D motion, for one-dimensional motion, vectors are very easy. We'll go through that really quickly. But for two-dimensional motion, this is where vectors really come into play for us. Okay, so first we have here what is a vector, right? So pretty much for anything in physics, we have two types of values. We have scalar values and we have vector values. When we have scalar values, I'm going to use this vocabulary that you may not be familiar with, so try to be comfortable with the words that I'm going to use because I don't want them to trip you up later on. You just think, I've had a lot of students ask me, so what's the formula for magnitude, right? Or you're asking for magnitude in a question, what's the formula for that? We don't have a formula for magnitude. So be careful. Magnitude is just a word that I'm using to describe amount, a number, right? So a scalar value has a magnitude. That is just a number, right? So I can put this here. This is an amount, or or a number. Okay, so when we talk about scalars, we're focusing on, let me go and slide this down a little bit. We're focusing on things that only have number values. They can be completely described only by the amount that there is. For example, mass, right? If I go ahead, here what I'm going to do is example, mass. When I talk about how much mass something has, okay, all I need to know is the amount, right? So if I talk about mass, the mass of a ball or a car or something, I can describe that just by giving you a number, and that's it. So I can say 12 kilograms, right? Something like that. That's all I need. When I'm talking about mass, I don't need any other information except for a magnitude, an amount. So a magnitude can be greater or smaller, right? It can be 20 kilograms in this case, or it can be smaller, it can be 2 kilograms. But that's it. It's just a number. Vectors are a little bit different. When I talk about vectors, okay, we have two parts here. One is magnitude and the other one is direction. So you may have seen this in the one-dimensional motion video when we have something that is, let's say, a ball that is moving downwards. And I want to talk about the velocity of this ball. Okay, the velocity of this ball actually has two parts. Okay, speed is just a scalar value. If I ask about how fast is this ball moving, that's just speed. I can say, oh, the speed right here is 3 meters per second, right? So this is an example of a scalar value. This is just speed, but this is not velocity. Velocity needs two parts, always needs two parts, and we'll get more into why this is later on, but it's important for us to know that velocity has two parts. One is the speed, right? The other one is the direction. So I'm going to do here is I'm going to mark this with a negative. Here in the case of one-dimensional motion, I have two parts. So here, and mark this, this is the direction, and this part right here, the number, is the magnitude. Okay, so I need both of these parts in order to describe velocity, which is a vector. So a few things that are vectors are displacement, velocity, acceleration, all of these things can be positive or they can be negative. Mass cannot be positive or negative. I don't have upward mass or downward mass, anything like that. So there's no direction for things like mass, right? This is just a value. This is just an amount, so it's a scalar value. So this is just a quick kind of recap on what is the difference between a scalar and a vector value. One of the things we're going to be asked on our homework and on our exam, our first exam, is going to be, is a certain value scalar or is it a vector? Pretty much, does it have a direction or does it not have a direction? That's pretty much what we're asking here. So now we're going to talk about two-dimensional vectors. Okay, this here is a sort of generic vector. So this can be anything. It can be velocity, it can be force, it can be anything like that. It can be acceleration. Here I've just labeled it as vector A, right? So be sure that you kind of take a look through the notes and the slides on vectors when we're going through this because it'll give you a lot more details. Right now what I want to do is just kind of run through the ideas here. When I have a vector, okay, remember, it has two parts. This arrow has two parts. It has a magnitude, and in this case, the magnitude is going to be the length of the arrow, or usually it will be labeled as a number here, right here. This will be my magnitude, right? So this will be my length, okay? And the other thing that this always has is direction. Remember, we got magnitude and we've got direction. So in this case here, I have to describe, right now we can say the direction is kind of up and to the right, right? Well, that's good for a rough estimate, but if I want to know the exact direction, we have to use something a little bit more exact. And in our case, it's going to be angles. So we have some angle here. If I say that horizontal, or this direction right here, is 0 degrees, this is like flat or horizontal, I can measure how far this line deviates from the horizontal, and that angle right there is my direction. Okay, so my vector here has its two parts. It's got its magnitude, it's got its direction. Now the important thing, how we're going to be using this in two-dimensional motion, is that we actually don't want to work with these vectors. They're weird, right? They have weird directions, and so it's difficult to describe their motion. It's difficult to describe how they actually work. So what we want to do is we want to split this up. And the way we do this is we take components. So any vector that I have, I can make it into a right triangle of some kind, right? I could always put a vertical leg on it and a horizontal leg on it to make one right triangle. Okay, be careful. I always have to have a vertical and a horizontal part that intersect each other so that I make a little right angle. That's what makes this a right triangle. I can't, for example, I can't make this a triangle, just say like, all right, here and here, I'm done. Because yes, this is a triangle, but it's still composed of weird vectors, right? So I don't want this. So I'll do this, and when I do this, what I end up doing is making components. Okay, so an important thing here is that now I've made a way for us to easily work with this vector. We'll see how this makes things so much easier for us when we do two-dimensional motion. But for now, I want you guys to really practice on being able to deconstruct a vector into components, okay, and identify what these are. So in our case here, we have two components that we're going to be working with. One is horizontal, or I like to label this as X. It doesn't really matter what you label it as, but just to stay consistent, we'll say this is horizontal. So if this is vector A, this is AX. If this was F, this would be Fx, right? So this little subscript just tells me what part of A is this, right? And this vertical side here will be AY, okay? So if I wanted to figure out what this is, I can always deconstruct this vector into a horizontal part and a vertical part. And both of these added up together will always give me back my original vector. Okay, so I have a few parts here. I've got a theta for my direction, okay, and I have a magnitude. My magnitude, remember, was just the length of my vector here, so I'm still just going to write this as A, right? So my components, what are these actually equal to? This is really important for us. So we have a certain set of formulas that we can use to always get back some value from this triangle, right? Let's go ahead and look at this. We have two sets of formulas. One is the Pythagorean theorem, okay? This is very useful because if I know two sides of my triangle, let's say I know A and B, I can find C. Or if I know A and C, I can find B. If I know C and B, I can find A. This is actually really, really good. If I know two sides of my triangle, I can find the third, right? So this is the form for Pythagorean theorem. So already we can see that this could help us if I knew my components. If I knew, let's say this was X and this was Y, I could use these together in my Pythagorean theorem to find what the length of this side of my triangle is, which is my magnitude, right? Here, this would be magnitude of a vector, this is X direction, plus my B vector, this is the Y direction. Okay, so here this is just saying I'm adding these two together, but actually in order for me to add them together, I have to do this Pythagorean theorem, right? So let's go ahead and I'll go ahead and get rid of this. I don't want to confuse you by adding them together out here and then having them squared here. We just want to always work with this squared version. So just so you know. But this doesn't include anything about the angle, right? So in order for us to work with, let's say, an angle in order to find a missing side or something like that, we have three trigonometry formulas. I'll tell you guys right now that this is, math-wise, some of the hardest stuff that we have in the class. So if you're looking at this, you're looking at these trigonometry formulas, and you think, well, I kind of remember that. Maybe I've taken this in high school, something like that, and I feel comfortable with, let's say, taking sine to the other side here, like I've done right here, or I understand the parts of what you're talking about when we say adjacent hypotenuse, then you should know that this is some of the hardest math that we have, so it's not going to get any tougher than this in terms of the math, right? So in terms of math, if you feel good with this, you're going to be fine in the course, right? If you feel uncomfortable with trigonometry, with these formulas right here, this is the time for you guys to review this and look through the notes and try to get some examples of finding out sides of a triangle with our angles. So what I have here is I have three formulas: sine, cosine, and tangent. Here, instead of saying A, B, and C, I have used opposite and a hypotenuse. So, and adjacent. So I have my angle here. Opposite is always the side opposite of the angle, right? I've drawn this little arrow. So in this case, it would be B, right, for this triangle. And adjacent is the side right next to it. This is important because my angle could be, it could be up here, right? If my angle was up here, the side, the adjacent, would be actually this side next to it. And the opposite side would be this side on the bottom. So it's actually important to use opposite and adjacent instead of just saying B or C or Y or X or things like that, because you never know if you're going to be given another angle, right? So I don't want to throw you guys off. So when we work with this, try to use this kind of picture right here. Remember that you can always have these notes. You can have these formulas in your notes with you. As long as you know how to use them, they'll be really helpful for you on homework or exams. So these formulas are really good because we can incorporate using theta. For each one of them, if I wanted to know what my angle is, I need theta by itself on one side of the formula. So I need to be able to move sine to the other side, cosine to the other side, tangent to the other side. And that's what I've done right here. I've kind of done this for you already, but make sure you understand how this works, how sine moved to the other side. In this case, all I did was I just did sine inverse to both sides, right? When I do this, sine inverse cancels with sine, but it leaves theta by itself. And sine inverse is on the other side. That's all I did, kind of like when we have a multiplied number and we divide it by both sides in order to get rid of it. That's how we've done this. So we can use these formulas just like this in order to incorporate our angle so that we can find, let's say, missing sides of our triangle or find the direction of a certain vector. So when we're looking for direction, these formulas are going to be super important. You're almost always going to use them. All right, guys. So we'll go ahead and try out our homework on vectors, and I can add in some examples if you guys are getting stuck on those problems. They are a little bit tricky, so try them out, and then if we're having trouble, we'll go ahead and post some more videos on examples working through these vector problems.